trying to figure out establishing, what threshold levels you should be using with your indicators to, I guess when you're taking various indicators. So it sounds like Milby's using a handful of oscillator type indicators, such as like the RSI, right? The MACD, the stochastics could be another example of an oscillator indicator. And he's trying to, I guess, back engineer or, optimize threshold levels for all these various indicators. So Milby, if that is your point, to do that, that's just trial and error, establishing thresholds. So that's not what BloodHound does. Yeah, BloodHound it's not an optimizer. So with BloodHound, you need to know, at least you need to have a ballpark idea, as to what indicator values, you're looking for when you're setting up solvers in BloodHound. So let's go to a chart. All right, so let's get BloodHound open here. And let's see, the first thing, let me put today's file name in. All right, so the 21st already. So we have a BloodHound file established. So let me just grab a threshold solver here to kind of help explain to everybody else in the room here what I think Milby's question is about. So, all right. So when you're using the threshold solver here, and let's see, Milby mentioned the MACD, so that's kind of a classic indicator to use with the threshold solver. So let's just plug the MACD in here. There we go. All right, there's the MACD. So let's say you wanted to analyze the actual MACD line. So that's already selected for us. But of course, if you wanted to, if you're using the average line, then you could select the average line and analyze the threshold values for that. So, but I'll just leave it on the MACD. Right. So Milby's trying to figure out, what kind of threshold values, would work. I guess would work best when he's trying to design his trade system here, or his trade signals. Let's see. Let's also add the MACD on the chart here. All right, just a moment while I get the colors set up here. All right, so back to the threshold solver here, right? So I guess let's take a step back. So the threshold solver, kind of its core use, the main way that you're going to use the threshold solver is, for oscillators such as the MACD here. And, so if you're using the MACD, sometimes you might just be looking for, is the MACD, sloping up, or is the MACD sloping down? But also but probably the most common use of the MACD would be, looking for the MACD to be, above some threshold level. Is the MACD above 2, right? So in this example, on the end Q, is the MACD above 2, or is it below 2? It's going to shrink this up, right? So also you might be wanting to know, so like for short trades, is the MACD below 2? And so you would use something like this, you put something like this in the MACD, right? And so the threshold solver here, right? So the threshold solver here, right, is going to tell you when the MACD is greater than 2 or less than 2. And so getting back to kind of Milby's question, which is, how to establish these threshold levels. And so, so you can see, from the threshold solver, and from all solvers, you have to kind of have a starting point to start with when using BloodHound. So BloodHound's not going to find those values for you. That's not what BloodHound's for. There are other software out there. Trying to think of the general term, but yeah, there are general kind of like AI algorithmic, finding software that will also at the same time kind of optimize threshold levels for you when you're using indicators like the MACD. So, but that's not what BloodHound is. So, with BloodHound, you just have to have a starting point, and then kind of build all your various threshold solvers using some values that you think are going to work, that you think are going to get you in the ballpark, and then it's just going back to the chart, and just analyzing your signals, then analyzing each indicator and the threshold level, and see if you can fine tune things from there. So it's just a matter of trial and error, going back and forth, making adjustments to your threshold values for each of your indicators that you might be using. All right, so in Milby's case, he's using a handful of indicators. So he'll have a handful of threshold solvers. And yeah, it's just a process, it's just a process of going through and making all those adjustments, to each threshold value for each indicator, using some trial and error, to kind of get you in the ballpark there. All right, so Milby, I hope I answered your question. Let's see, yeah, Spike is asking, does the threshold have to be a constant, or can you substitute another indicator cross as a threshold? Well, I'm not sure what you mean by an indicator cross, but to answer your question, yes, threshold levels are constant. You do have to put a known value in there. While these values, are adjustable in that you can type in a new value, at any point, you can go in and just type in a new value, but these threshold levels cannot be automatically updated or automatically adjusted by using another indicator, or even using. Bottom line is there's no way to automatically change these threshold values. So, yeah, like for example, I am using the MACD in this example here, and anybody who's familiar with the MACD knows that the values of the MACD will change based on the instrument price. Yeah, so if you are using the MACD, probably what would be better, if you're using the MACD with a threshold solver, probably what would be better is to use the PPO indicator, right? Because the PPO indicator is normalized. It's normalized, so the instrument price won't affect the values coming, that the MACD generates. So, but if you do need to use the MACD and you're trying to build a system that'll work on different instruments, well, you're going to need, different threshold solvers for each instrument. Right. So, like for this one, I could just say this is the MACD, tuned for the NQ instrument, something like that, right? Type that in the name of your solver there, right? And so you'd want a threshold, or let's just say you'd want a MACD threshold solver for each instrument so that you can tune your threshold levels to match that instrument, since the MACD is constantly changing itself, changing the values, right, for each instrument. So, okay, so great. So Milby's provided me some threshold values here for the NQ. All right, so he's using a MACD. He's got some custom settings here, but let's see. He's using a threshold value of 2.5, 5 and 10. So he's, all right, so his question is, he's just kind of interested in the process, I guess, of determining what, I guess you're trying to figure out and determine which of those 3 threshold levels work best, with your system. I'm guessing that's kind of what you're after there. So, all right, so let's see. Let's make some adjustments here so that I'm using Milby's settings here. So, all right, let's adjust the MACD here. So with the MACD, he's using a period of 5, 20, 30. All right. And let's see here. All right. Yeah, so yeah, that gets the MACD up to that largest threshold of 10. Okay. So I'm just going to put some lines, these vertical lines here on the chart so that we can see those threshold levels that Milby wants to use. All right. Yeah, so if you're using, an oscillator type indicator and you've got, a couple of threshold levels in mind, but you're not sure, kind of which threshold value, is going to work best with your system. Another classic indicator, that kind of falls into the same kind of realm as like the stochastics, So like, for example, is looking for a stochastics value greater than 80, the best choice, or should you be using something like 75? Is using a value greater than 75 with the stochastic better? So Milby's kind of getting, again, back to Milby's question, what's kind of the process of trying to figure out, which threshold value is going to work best with your system. So kind of the fastest way of, determining or kind of like back testing some results, being able to do some back tests using the 3 different threshold levels here. The best thing to do, I guess, a good process of trying to quickly, analyze each threshold level, would be, that's it. So let's set up these solvers first here. All right, so let me set this first solver up here. All right, so we're looking for 2.5 on the MACD. And we'll just note this is for the NQ. All right, so we have one threshold solver set up, right, with using the 2.5 threshold level. So I'm going to make a copy of it. And this second one will be looking at the threshold of 5. So, well, also, hold on, let me take a backtrack here. So typically what people want to see with the threshold solvers, they want to see a digital output here. So, right, if you look at BloodHound on my chart here where my cursor's at, right, you can see we're getting an analog kind of an output. Right? So most people want to see kind of a nice, clean, crisp digital outlook. So the way you can do that is you just put in your values twice, right? So I put in 2.5 twice and negative 2.5 twice. And so now if I turn off, I need to turn off the second solver. So now I just have the one solver turned on. Right, so there you go. So now we have a nice clean kind of digital look here. Also, before I get going too far here, let's delete this. We need to change the indicator settings here. So let's go into the solver. Sorry guys, I'm going a little too fast here for some new people here. So let me just kind of explain here, right? So we can see the indicator settings here in the solver, right? And so the solver, the threshold solver, still has the default indicator settings. right? But if you remember on my chart, I changed the indicator settings to what Milby's using. So I need to change the settings in BloodHound, right, in the threshold solver. So I'm just opening up the indicator window again, right? And then you can see the settings up here on the top right. So we're using 5, 20, and 30. There. All right. Yeah, so always, make sure that, right, so there's my indicator settings on the chart, and always make sure that, the indicator in the solver is using the same indicator settings, right? Always make sure those indicators settings are matching up there. So, all right, so now as we do that, now we can see on the chart here, right, whenever the MACD goes above the 2.5 or below 2.5, we're getting short, right? Short or long outputs here. All right, so we've got this one solver set up. So now let's go set up the other two solvers. So I'm going to make a copy of it. So now this threshold solver is going to be looking for a threshold of 5, right? So we're going to change our thresholds to 5. Like so. There. All right, so there's another threshold, the second one, and now let's make the third one here. That's going to be looking for a threshold of 10. There. All right, so I have my three threshold, excuse me, my three solvers there, right, with all different threshold values. So now I'm going to switch over to the logic tab, right? So this whole time I've been working on the solvers tab here. So now let's switch over to the logic tab, and let's create a new logic template here, right? So, all right, so I'm going to make one logic template that, and I'll give it some kind of name, that kind of tells me, what threshold values I'm using for the MACD there. All right, and so what I'll do is I'll put, the solver. So let me back up here. So I went to existing nodes, all right, and there you can see there's the 3 threshold solvers that I just built, right? The 2.5, the 5, and the 10 threshold levels. So I put the 2.5 on here, right? Now this isn't, keep in mind guys, this isn't a complete picture, right? So normally, you'd probably have an AND node, right? And you'd have the rest of, your system in here, right? They have the rest of your system here. And the point is that, this particular logic template is using this specific solver, that's using the 2.5, right, or the 2.5 threshold values. Right. So what you want to do is you want to build the rest of your system here. Build the rest of your solvers. Connect them all in. Build your system, and then you'll want to just use this one particular solver here. So I guess just to kind of make a little more complete picture, I'll just throw in a little generic bar direction. So this bar direction will kind of represent the other solvers in your system here. All right. So once you've got one logic template built here, then what you can do is you take this logic template, hit the copy button, and hit the copy button. There we go. So there's our copy, and I'm going to rename it first. So there we go. So now this logic template, instead of, it'll be using the threshold solver with the MACD of 5 threshold level, right? And connect that in, right? So I now have 2 logic templates, right? And the only difference between these logic templates is just the MACD threshold level, right? The only difference is the solver that's looking at different threshold levels. Okay, so I've got this one, so let's make another copy, and let's adjust the name up here. There. So to get rid of that threshold solver, and then go and add my MACD 10 threshold level solver. Let's move that over, connect that up. All right. So there we go. So now I have 3 logic templates, each using a different threshold solver with a different with the different threshold values or levels. And so now what you can do is on the chart, right? So now on the chart I can switch between each system using a different threshold value, right? So I can look at the 2.5 threshold value, right? And I can analyze, I can just kind of visually analyze the chart, look through the chart and see, do I like, how do these signals here, compare to, the other threshold levels. So I'll select like the MACD 5, and look through, and, basically you're just now gonna visually, manually visually look at all the signals generated with the MACD of a threshold level of 5. And then so on, and then next switch over to the MACD 10 threshold level. And then analyze those signals and see, well, do those signals even look better? Do those work better for me? So, all right. So, there you go, Milby. I think that's what you were asking. And also, excuse me. Also, guys, if you'd like some more, in-depth training on the threshold solver, then let me show you how to find that quickly here. So, like if you're wanting to understand how the long output and the short output works, how do you know which output, do you want to use for the short? How do you know which output you want to use for the long? How do these threshold levels work? How does A, B, C, D, and E, how do they all work together? Then let me show you where that in-depth training video is here. So what I'm going to do is with BloodHound open, I'm just going to go to Help, and then you can go to the documentation there. And let's see, for BloodHound, so if we take a look on the side menu here under BloodHound, what we're going to do is go down to the solvers here, right, the confidence solvers, and here is the indicator threshold right there. So we can click on that. That'll take us to the threshold solver page. And if you scroll down, there's a video for it. All right, so this video goes into great detail of how that threshold solver works. So it'll explain, how to use the fuzzy logic part of the solver. It'll explain, it'll help you understand, how using like these numbers, these threshold values twice, it'll help you understand how that gets rid of the fuzzy logic, So, so there you go. A video for the threshold solver, right, on the threshold solver page. Milby's got a question about the threshold values here. Yeah, so let's click on this here. Yeah, so you'll note here at the bottom, right, there's kind of a description, right, a little help topic there. So I have A, right, threshold level A selected here, right? You can see it in blue, highlighted in blue. And the comment here says set A to the highest threshold value, right? And then if you click on E, it'll say set E to the lowest threshold value. And let's see, C, yeah, set C to a middle threshold value, equal or less than B, but greater than D, right? So all these descriptions here are just letting you know that the threshold values need to be placed in descending order. All right, so if you notice, I have 10, 10, 0, and then negative 10, negative 10, right? So they're in descending order. Yeah, like for example, let's say, let me switch over to the solvers tab here, and let's grab a brand new threshold solver. I'll add that, right? So let's say you wanted to use the stochastics with the threshold solver. So let me just plug the stochastics in there quickly. Let's say you're looking for, when the stochastics is greater than 80, right, or less than 20, right? Now, the way the threshold solver works is you can't do it this way because they need to be in descending order, right? And so the problem is that C, actually, I'm sorry, this is in descending order. So this actually would work, but problem is if you wanted to look for less than 20, well, if you look at the descriptions here, for a short output, we have at 20, then we have at 0, or less than 0. All right, so putting 20 up here, you can find when the stochastic equals 20, it's at 20, but you can't find it less than 20 because E is at 0. So if you look at the description, it says less than 0. So what you'd really want is you'd want to put the 20 down here, and then when you see the description, it says less than 20. So there, so that'll find values there, right? That'll find values, when the stochastics is less than 20, or if the stochastics is greater than 80, right? But again, the problem is we're B, C, and D are no longer in descending order, right? Because 0 is less than 20. So what you need to do is put a value in the middle, some arbitrary middle value in there, right? So obviously 50 would be the midpoint of the stochastics. Right. So I could do something like this, right? So if you're looking for a stochastics, greater than 80 or less than 20, then for C, you could just find some middle value and put that in. That way all the threshold levels are in descending order. And let's see, Milby's, all right, so Milby's got a follow-up question here. All right, so Milby's trying to understand how one solver works with several thresholds. Well, typically the way people want to use threshold levels in their system, one solver won't do it. But what one solver can do with multiple threshold levels, so let's go back here. Let me delete this, and let's go back to the logic template here. All right, so I'm gonna use the MACD 10 threshold level. So if you wanted to use other threshold levels, so let's put 5 in here, and we'll put -5 in here, right? So you can see that really the threshold level can only work with two different threshold levels, right? There's just not enough options in here to use 3 different ones, so you'd have to use multiple threshold solvers to do this. But yeah, so the only way that the threshold solver can work, or I should say that the only way that you would use a single threshold solver using multiple values is in a fuzzy logic situation. So let's say when the MACD hits 10, you want to get a 100% output, right? So that your confidence level with a MACD at 10 is 100%, right? So if you look at the outputs here, greater than 10, we're setting 1, which means 100%, right, in math terms. So let's say if the MACD hits a threshold value of 5, then let's say that gives you a 70% confidence, right? So then at 5, so for the long output, at 5, I'll put 0.7 for 70%. And also I'll do the same down here for the short outputs. Let's put 0.7 down here at -5. And now if we take a look at the chart, squish this up here, right? What you're building is a fuzzy logic confidence output, confidence values, right? So as the MACD rises, as the MACD gets higher and higher and closer to 5, then you can see the output value is going to rise and rise and rise. So so if you're going to use multiple threshold levels, then the only practical use is to start using BloodHound's fuzzy logic for that capability.